Hello and welcome to another math video. Today we are going to be taking a look at the rectangular coordinate system. A few points to make about that. When we've got our XY or rectangular coordinate system, the point where the X and Y axes meet is called the origin. The X axis is our horizontal axis and the Y axis is the vertical axis. The coordinate grid is broken down into 4 quadrants, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We have a few points here to help demonstrate how our coordinates work with our ordered pairs. So point A is the ordered pair 3, 1, so from the origin it's right 3 up 1. Point B is the ordered pair 4, negative 1, so from the origin right 4 down 1. Point C is the ordered pair negative 5, 6. So from here it's left 5, up 6. Point D is the ordered pair negative 4, negative 5. So from the origin left 4, down 5. And finally point E is negative 5, 0. So from the origin it's just left 5. Again, hopefully that helps to remind you about how the XY coordinate system works. So again, the first number is the X coordinate. That's your horizontal position, either left or right of the origin. And the second number is the Y coordinate. That is the vertical position, either above or below the X axis, the origin. And again, if we get a 0, like here with the Y, then it's right on the X axis. Here we're going to look at completing ordered pairs and making a table for an equation. We've got 2x plus 3y equals 6. So we're going to complete the ordered pair negative 3 for x, and then we're going to figure out what y is. So the way that we do that is we take the equation that we're given, plug the negative 3 in, and then that leaves us with an equation with only one variable, so we should be able to solve that. That gives me negative 6 plus 3y equals 6. I would add 6 to both sides of the equation. That would give me 3y equals 12. Divide by 3 would give me y equals 4. So negative 3, 4 is that ordered pair. In part B, they give us the y coordinate. So we would replace y with that, so y is a negative 4. So that would give me 2x, really minus 12 equals 6. So then we would add the 12 to both sides, give us 2x equals 18. Divide by 2, we found out that x is 9. So that completes that ordered pair. It's 9, negative 4. So we can make that into a table. I'm going to go with a horizontal table here because that's the kind of space that I have. Let's see, so the first ordered pair was an x value of negative 3 and a y value of 4. Second ordered pair was an x value of 9 and a y value of negative 4. We could go ahead and graph that equation since we have a couple points for it. So if I plot negative 3, 9, that would be right up here. And then 4, negative 4 would be down here. Now those are fairly far apart, so you're going to be very careful how you graph those. I might try to figure out what the slope is between those. So, although in this case it doesn't look like that's going to be too helpful. So I might just do my best to draw a line connecting those two in order to see what that would look like. Here we've got a table of values for x minus y equals 3. Again, you can see they've given us either an x or a y. We have to find the other value, and then we'll graph the equation. So for the first one, when x is 0, we need to find y. So we get 0 minus y equals 3. So really y is negative 3. When y is 0, we get x minus 0 equals 3. So really x is 3. If x is 5, we get 5 minus y equals 3. So we would subtract the 5. We get the opposite of y equals a negative 2. So then y would equal a positive 2. And if we look at the last one, x is 2, so 2 minus y equals 3, we could subtract the 2, get negative y equals 1, or the opposite of y is 1, so then y would be a negative 1. Let's see, if we look at those points, starting from the top, we have 0, negative 3. So from the origin, we don't go left or right at all, we just go down 3. Then we have 3, 0. So from the origin, we go right 3, but not up or down at all. We have 5, 2. So from the origin, we go right 5, up 2. And we also have 2, negative 1. So from the origin, we go right 2, then down 1. It should look like those are on a line. In this case, it looks like, based on that graph, the slope has a line, or the line has a slope of 1, I should say. So we can connect those points and see what the graph of that line looks like. Here we're just looking at some first degree equation information. If you want to go ahead and pause and read through that, it can be helpful to understand these things in more than just the application sort of a sense. Here we're going to take a look at a method for finding or graphing a line called finding intercepts. So if we have an equation like this one, 4x minus y equals negative 3, we could find the intercepts for that. In order to find the intercepts, when we're looking for the x-intercept, we have y equals 0. We're looking for the y-intercept, we let x equal 0. So really, if we make a table of values, if we have x equals 0, we can find y, and have y equals 0, we can find x. So first of all, if x is 0, that gives us 4 times 0 minus y equals negative 3. So a negative y equals a negative 3. So y would be 3 when x is 0. And if y is 0, we get 4x equals 4x minus 0 equals negative 3. So really divide by the 4, we get x equals negative 3/4. So we don't get 2 nice points, but at least we get 1 nice point. So that point being 0, 3. And we have negative 3/4, 0. So not the easiest thing to graph that. In this kind of case, I might do one of two things. Either look for another nice point or try to determine the slope of this line so I can get a better graph. Up to you which one you would like to do there. In this case, I can tell that the slope is going to be just a positive 4. So that means if I have a negative 1 here, I would get negative 1 for x and for y. I could double check that in my equation to make sure that works. But that certainly is what we would have here. So we can graph that, and then we can get some nice points there using that slope. And the graph would look something like that. Here's a graph for you to try, so if you want to pause and work through it, then when you resume, I'll go ahead and go through the problem. So first, finding the x and y-intercepts. Again, if we make a table, plug a 0 in for x, find y, plug a 0 in for y, and find x. So when x is 0, really we're left with 3 times y equals 12, because of course the 2 times 0 is gone. So y turns out to be 4. Likewise, when y is 0, then we're left with 2 times x equals 12. So divided by 2, we get x is 6. So that's why finding those x and y-intercepts are so nice, because the zeros make those points go away. So we've got the point 0, 4 for the y-intercept and 6, 0 for the x-intercept. Now somewhere I would want you to state which one was which, just so I know that you know which one is which. Sometimes people mess those up or switch them around. So if you do it on the graph, maybe you say, this is the y-intercept here, this is the x-intercept here, or if you would do that on the table, y-intercept there, x-intercept there. So something like that. We do need to finish graphing. Now I would look at this and see that from one point, from the 0, 4, you go down 4 and then right 6 to get to the other. So slope of down 4, right 6 reduces down to negative 2/3. So that gives us a couple, or a point in between. And then we can do down 2, right 3, or up to left 3 in order to come up with some more points. So should be able to draw a nice line through there in order to graph that equation. So graphing horizontal and vertical lines sometimes tends to mess with people. So try to explain it in a way that you can think about. And I think people have a hard time with it because they try to memorize what does what rather than understand what does what. So if you can understand it, then you can recreate it if you forget it. If you try to memorize it, then if you forget it, then it's just not going to work. So we're going to start with the equation y equals 2. So a good way to look at that is make a table of values. No matter what, the y value has to be 2. That's what the equation says. So you can change the x values around as much as you want. The y value is going to be 2 no matter what. Once you take a look at that, you see that you get your 3 points, and you can draw your line through there. So it does end up being a horizontal line. I think people get confused, like I said earlier, because they try to memorize, and they know that y is the vertical position for your point, so they see y equals 2 and they want to make it a vertical line. But again, the problem is when that vertical position is set, then you have a line that follows that vertical position, you get a horizontal line at that particular height. Here they try to hide a little bit, have an x plus 1 equals 0. You can subtract the 1 and it becomes just x equals negative 1. So they go through a little bit of that there. Same sort of thing, you can make a table. The thing is, no matter what, the x value is negative 1. You can pick whatever you want for the y values. They do negative 4, 0, and 5. So you can see you plot those points, they're all on a vertical line. So you can connect those and get your vertical line. Again, people get confused when they try to memorize because we think of x as the horizontal position, so they want to have x be a horizontal line. But again, when that horizontal position is set, you draw a line through that and you get a vertical line. Here's a couple for you to try, so if you want to pause and then do those, then resume and I'll go through them. So number 43, y is equal to 5. So no matter what, y is 5. So you might start just plotting one point with a y value of 5. So that's 0, 5. You could pick anything else. I'm going to go 10, 5 and negative 10, 5 just to spread those out a little bit. So all three of those points have a y coordinate of 5. And so we can connect those. We see we end up with a horizontal line at y equals 5. Here they try to hide it a little bit again, but just subtract the 4. We see that x is equal to negative 4. Again, if you plot some points that have x coordinates of negative 4, negative 4, 0, maybe start with that one, negative 4, 10, and negative 4, negative 10. Again, then I get points that are very well spread out. And we can see that those will form a vertical line when we graph that. So again, x equals a number is a vertical line, y equals a number is a horizontal line. Again, it really just comes down to, like for number 43, y is 5. So no matter what, y is 5. For 47, x is negative 4. So no matter what, x is negative 4. So yeah. Here we're going to take a look at how finding the intercepts can sometimes not be enough. If we make a table for this, they want us to find the x and y-intercepts, plug a 0 in for x and a 0 in for y. Well, the problem is if I have x equals 0, then we get 2 times y equals 0. Divide by 2, we find that y is also 0. So when x is 0, y is 0. You could do the same thing when y is 0 to find out that x is 0, but it's just that one point. So in the case where the graph goes through the origin, that one point is both intercepts. So both the x and the y-intercepts are 0. It's that one point covers both. So if we're going to graph that, we need to come up with some other point. There's a few different ways to do that. We could just extend the table and see what happens, and if you wanted to pick y values, you could do that as well. Either way, doesn't make a huge difference. So we could just fill in at least enough of that table till we get at least one more nice point to graph, or we could try to figure out what the slope is. Either way is about the same. Again, we know how slope-intercept form works. So if we go x plus 2y equals 0, we would subtract the x. We get 2y equals negative x. Divide by 2, it ends up simplifying down to negative 1/2 x. So we can see, well, hey, the slope is negative 1/2. So from the origin, which is a point on our line, we can go down 1 right 2, and we could continue to do that for as far as we wanted to. And we could also switch that around and go up 1 left 2 if we wanted to go to the left as well. So you can see we could get all those points. Now, looking at our table and how the graph turns out, you can see that when x is 1, we don't have a great point, and actually my graph isn't that great because it should look like it's at negative 1/2. So if you were using the table, you plug a 1 in for x, you get negative 1/2 for y. Plug a 2 in for x, though, and you get negative 1 for y. So if we wanted to, we could have done that and come up with that point. And then once you have those 2 points, it's easy enough to see that the slope is negative 1/2. So again, the table would have worked pretty well also. Alright, so we're going to take a look at using the midpoint formula. And actually, even before we get to the midpoint formula, I want to show just a visual way of kind of figuring out the midpoint. We're going to look at the midpoint between P, which is negative 8, 4, and Q, which is 3, negative 2. So that midpoint has to be on that segment connecting those 2 points. One thing we can do is we can drop a vertical line down here and do a horizontal line this direction. And where they cross, we get this kind of extra point. They called it capital R, which is at negative 8, negative 2. Now, the midpoint has to be halfway along PR and halfway along RQ. PR has a total length of 6. So halfway would be 3 and 3. So if we're at 4, height of 4 for P, and if we go down 4 to get to M, or down 3, I should say, then we get to 1, which again it should look like that's what's going on there. Now from R to Q, we're going from negative 8 to positive 3, so that's a distance of 11, so half of 11 would be 5.5. So it's 5.5 to the right of negative 8, 5.5 to the left of 3. That ends up being negative 2.5. So negative 2.51 would be the midpoint for that. So just a little bit different way of just visualizing how we can figure out what that midpoint is. Now, the kind of technical way of doing that is to really just average the x-coordinates. So if we add those x-coordinates together and divide by 2, that's the average of the x-coordinates. In this case, that would give us that negative 2.5. So that gives us the x-coordinate for the midpoint. And then we do the same thing with the y-coordinates. Just average those y-coordinates. And that gives us the y-coordinate of the midpoint. In this case, our x-coordinates are negative 8 and 3. And our y-coordinates are 4 and negative 2. So 4 plus a negative 2. And again, it's always divided by 2 because we're averaging 2 things. So we get negative 5 over 2 and 2 over 2. Now, of course, we'd want to simplify. No problem with negative 5 over 2, really, but then the 1, of course, as well. So that gives us our midpoint. So that's our midpoint. Kind of technical, formulaic way of doing that. But also we have that visual way that you can use, which can help see what's going on. Here's that midpoint formula. Again, really just averaging those x-coordinates for the x-coordinate of the midpoint and averaging the y-coordinates for the y-coordinate of the midpoint. And of course we're using subscript there, like an x sub 1, y sub 1, so we can use x's for both of the x's, x sub 1 and x sub 2. So first we're going to take a look at finding the midpoint for 4, negative 3 and 6, negative 1. Now they don't ask us to graph it or tell us to graph it, but I want to. So 4, negative 3 is down here. 6, negative 1 is right here. So we can tell that that midpoint is going to be right between those. And so this visual approach really pretty quickly, from one to the other, from P to Q, it's up 2, right 2. So that midpoint has to be right in between, so up 1, right 1. So that visual approach right away gets us to what our answer is. It's going to be 5, negative 2. You could use the formula as well. Again, you just average those x coordinates. So 4 plus 6 over 2. And average the y coordinates, negative 3 plus a negative 1 over 2. And so we get 10 over 2 and negative 4 over 2, which of course leads to 5 and negative 2, like we saw. If you want to go ahead and try number 55, go ahead and pause, and then when you resume, I'll go ahead and go through it as well. So here we're looking at negative 8, 4. Again, they don't ask us to graph it, but it can be helpful. So negative 8, 4 is there. Negative 2, negative 6. Make sure I've got that in the right place. So there's that. Now, here they're a little further apart. I can't necessarily just look at that as quickly as we did the last one. If I draw this line down here and this one over here, then we can see where those cross. So we get negative 8, 4 is here, and negative 2, negative 6 is there. Right, that's a little better. I wanted to zoom in a bit on that. So where they cross, of course, would have an x coordinate of negative 8 and a y coordinate of negative 6. That's where they cross. So the height distance from negative 6 to 4 would be 10. So if I just go up 5, so 1, 2, 3, 4, 5, I get to where that midpoint would be. And then from negative 8 over to negative 2, that would be a distance of 6. So if I just go right 3, that's where that would be. So straight up from here, straight over from here, gets me to where that midpoint would be between those two. And of course, it should look like it's on the line connecting them. And looks like negative 5, negative 1. Of course, if we use our formula, we should come up with the same thing. So if we do negative 8 plus a negative 2 over 2, and we also do 4 plus a negative 6 over 2, so we get negative 10 over 2 and negative 2 over 2. So that again leads us to the negative 5, negative 1, like we should be getting there. So, well, hopefully you found this helpful, and thank you very much for watching.